Hello, everyone. Good to see some familiar faces. Good to meet some new faces. Uh, my name is Antanas, for short, and I actually live in London. I've been there for like 20 years. And today I want to talk about context engineering. So, one of the challenges I'm trying to solve for some of the largest corporations in the world is context at scale. And today I want to share some ideas and some techniques of how we manage context at scale and especially in production. Please come in. Just quickly want to have a feel of the audience's expertise in, let's say, AI in general. Like, do most people use AI on daily basis? How many of you are AI engineers? Context engineers? Yep. Okay, cool. Uh, Simone and I were having a chat yesterday over pizza about how technical those conversations should be. And most of the time, we're trying to make it not too technical, not too deep. And if that sparks your interest, please do reach out and we can have a deeper conversation. So today, we'll touch on some approaches like write, select, compress, and isolate in the context engineering context. Right. Just to confirm that I'm not affiliated with anyone. I'm just here as myself, but I do work for some of the large corporate organizations in the world, and I do partner with companies like LangChain and others. Okay, shall we start? So most of us start our agentic journey with a simple hello world type of a loop, right? And this approach is perfect for just getting started at small scale. But what happens when you put it in production? Especially if you have a lot of users, right? A lot of users, which means a lot of context. People start dumping everything they can into the context window without appreciating the limits. Most people just look at an LLM's context window. Let's say we take some of the bigger models like Gemini family and context windows of like 1 million tokens, and we think, oh, that's great. That means I can just throw in everything and it will reason, it will be great. Unfortunately, that is not the case. It is far more complicated than just dumping everything into that context window. Okay. So what's a context trap? Uh, you've guys heard of context poisoning? Most of you probably have. For those who haven't heard of it, this is one of the reasons why LLMs hallucinate is when you basically confuse them. You confuse them with contradicting information, with too much information. So just imagine you have a chat with your agent, and every time you send a message, what it does, it takes the history and then it sends it again, right? It's not that LLM remembers. No. Again, my AI engineer fellows know that every request just builds up that context and you keep sending it, right? And if you're not careful, you start context poisoning. There are some other terms as well, like confusion and other terms, which make it very hard for LLM to give you accurate answers. And secondly, obviously latency. So more context you send, longer it takes for it to respond, and it costs more because you pay for input tokens, and guess what? You pay much more for output tokens. Right, so the cost is another thing which you have to be careful as you start building up your context window. Okay, and the trap is simple. Most of us think, I'm gonna be all right. It's gonna be fine. It's the user's problem. Um, so the solution. Anybody used LangChain in the room? Heard of LangChain? Ah, great. For those who haven't, have a look. LangChain is the company who developed LangChain. that's their first large language model framework or AI framework. And then they've built other products like DeepAgents, which we'll talk about today. And DeepAgents is an agentic library which comes with some tools, or they also call it the middleware. And those tools allow agents to do things in a more optimal manner. And we will talk about some of those pillars. So let's start with write. Now, you don't want to keep everything in the memory. Therefore, you use write into the files. So you offload basically your context, right? So you keep your context window clean, and then you select, which means you retrieve only what is you need, because depending on where you are in your agentic workflow, it's not that always you need to keep that context, right? Let's think. It's when I think LLMs, I try and think how humans operate, and we know a lot of stuff, but at the very high level, at the very abstract level. And when we need to retrieve something in more detail, uh, let's take some frameworks. I don't know. Let's take Django frameworks and some of the functions. I'm sure it's very hard for everybody to memorize all of the functions, but you know that they do exist and you roughly know what they do. And if you need to extract them, you either go and look up in the docs or you just ask your LLM. So select is when you select just in time only what you need. The third pillar is isolate. And this is an interesting one because uh, that is a boundary between your regular chatbot and a proper agentic system. An agentic system which can go and spawn sub-agents to do smaller tasks which will help with overall context window cleanliness rather than your main agent going and doing, let's say, research, pulling a lot of information into its context window and just getting confused and basically the context window getting messy. And the last but not least is compress. So we again use techniques like summarization where we compress the context. Also, compress applies for subagents because when subagent goes and does its deep research on a specific topic for your main agent, we call him, let's say, a supervisor, the subagent will summarize and respond only with the information required for your orchestrator or your main agent to proceed with the next task. Okay? So let's deep dive into each one of those pillars. First one is write. As I said, you are offloading your context into the disk. It is as simple as writing into a file. Now, you can go and either implement the writing tool yourself and all of the logics, or you could go and use frameworks like DeepAgents, which give you all of the tools out of the box as part of that framework, as part of the workflow, so it is much quicker to go into production. Um, as you see, this approach clearly decouples execution state from a conversational history, and you will be able to access only when you need, which takes us into the second pillar, select, just-in-time retrieval, and as I've mentioned, do not force LLMs to parse massive documents directly inside of its prompt, right? Agents must dump raw search data or logs into file system immediately. And then use targeted read tools to extract the information. again, most in the room probably are aware of commands like grep and others, which help you to extract correct information or help you search the files. And that's what we equip our agents with, right? Think of your agent as a virtual employee or a developer which has access to your machine, whether you're on Windows, Linux, Mac, doesn't matter. And then you need to give it the tool. So you need to wrap the orchestration engine with the tools baked in so it can go and execute those commands, whether they're shell commands or maybe some API calls, right? Just again, think of agents as your colleagues, virtual colleagues who sit in the laptop, and sometimes they respond, sometimes they don't because you've hit the API limits. um, Third one, isolate. So a bit deeper, as I mentioned, we have a manager agent, supervisor agent. It doesn't matter how you call it, but we have the main process, which then orchestrates all of our sub agents. And the main process, usually, as a manager, it needs to know the abstract about your task, and it needs to know abstract details about some of the subtasks. So it keeps track of the to-do list, it keeps track of the state, but it does not keep all of the detail in its context window. Although we have worker agents, and there can be hundreds, thousands, like again, we were having a discussion yesterday, and we were debating about, is it worth spawning, I don't know, 1,000, 10,000, a million agents? Well, it depends. Some use cases do require that, especially deep research use cases, which need to process a lot of information. So if let's say a research task requires to crunch a lot of data, then and it's not able to be done by one sub-agent, what you would do, you would split that task into smaller pieces and then deploy it to multiple agents. And then you might want to reiterate and continue looping over and over again, which means every time you're spawning a new sub-agent, and you. So yes, it could scale, and I do have use cases where we would spawn 1,000 or more sub-agents for a deep research task, which takes, let's say, 30 minutes. And the last not least, handoff. The handoff is when the worker agent finishes. It must not return the entire reasoning trace, but just the relevant information for the manager agent. So the complex execution traces must be compressed into concise, information-dense reports, which then are used by the manager to take next steps. Right, I've prepared a very short demo for you guys to show how we can use these tools using DeepAgents library, and we compare that with a traditional approach, and then we can look at the benefits of that. So let me quickly switch to my other screen. Is that okay size, or shall I increase it a little bit more? Can you see? Perfect. Right. I'm not going to go into each file. Let me just quickly just get rid of that. So what I have here is a challenge, right? And the challenge is a massive log. It's a 50 meg file with some information, right? Logging information. It doesn't matter what it is. What matters that the file is massive, 50 meg, right? What I want to do is I want AI to go through that log and find me a key which will unlock a file, right? So it's just a cipher key, and it goes and decrypts me a file, right? And I've implemented two agents. One is a standard agent. Again, I'm using LangChain, as you can see here. LangChain create agent function abstraction. I'm giving it some tools, right? So as we discussed again, it needs to be able to read the files from my file system. So I give it a read file tool. I give it a write inventory tool so it can manage the findings and store them, and then run the vault. So this is my Vault Cipher file, which I want to be unlocked with a key, right? I'm going to be using the same prompt for both agents. So if we go here, we don't need to go into details, but basically what I'm saying, this is the workspace. In the workspace, we have a log file. I want you to go into that log file and find me the key, and you will find the information about when that event happened in a different file, which is a desk note file, right? And then I want you to use that key to unlock the file, right? A very simple task, sounds quite easy. So that's a very simple implementation of my agent. And what I'll do, I'll actually run it now. Whilst it's running, I'm going to quickly switch to the DeepAgents. A very similar setup. The only thing I have specified a sub-agent and some instructions for the sub-agent, and then using the same system prompt right here. Okay. So you can see at the bottom that our standard agent has failed, and it's failed with the request too large, right? I'm using a GPT-5.4 mini, but you can use any model. Like even if I use the 2 million context window model, that will fail. It will just take much longer. So what it tried to do, it tried to take that file and send it to the LLM, and the LLM was like, oh, well, actually it didn't even get to LLM because the API responded like, look, guys, don't be silly. We can't process that big of file. And I'll do the same with DeepAgents, right? So as you can see, very simple example. They have exactly the same tool sets. They have exactly the same system prompt, but one is a standard agent. It's just one LLM, cool. And another one is a DeepAgents library, which manager will spawn a sub-agent, and that sub-agent will go and do the work and then respond to the main one, and the main one will go back into the Cypher file and unlock that. And as you can see in the console, it has extracted the key, and then it did unlock the file. If I quickly switch to apologies. If I quickly switch here and do a refresh, that's Langsmith. Again, for some of you who are not aware, Langsmith is the tracing tool by LangChain. This is just to visually show you what happened under the hood. Ignore the first two because I ran them in the morning just in case if the demo gods decide to punish me. But the last two runs, we can see the first one. It did try to send. API responded with 429 saying that the file is too large. You've already seen that, right? So it did not manage to complete the task. The consecutive one, which is our DeepAgents, you can see many tool calls. So it's doing the to-dos list. So it's understanding the task. It's creating to-dos list, then it's going through the to-dos list, and we will see that it will be handing off the task to our log hunter sub-agent. Log hunter sub-agent then goes and processes the file, uses grep, one of the commands I've mentioned. Now, unless you specify what to use, sometimes they might decide themselves based on their training data, based on the context. They might use some different tools to go and search files. Or you can restrict it to very specific, but then you'll have to use your own tools. You'll have to write your own tools, or you can do it in system prompts as well. Anyway, and we can see the entire trace. Then it gets back to the main agent unlocks the file. Okay, this simple demo just shows us why it is important to manage our. Let me go back to the correct screen. I do apologize. Let me start again. Sorry, technical issues did get me at the end. Slideshow. Okay, and I should be able to change the screen. Yes, perfect. Thank you. That's the correct one. Um, so what did we see? With the standard agent, it's more of like a brute force approach. It's like, okay, let's just try and get it done. And of course it failed for a very, very simple reason. Again, this example was not meant to be super complex. I just wanted to give as simple as possible and as understandable as possible example out there. But you can imagine that there are many, many, many use cases where your simple approach will fail because of the context window. And with deep agents, obviously it's precision retrieval. We kept our context window small. We've delegated to sub-agents. Um, and it's highly deterministic as well, because you can scale this approach again to hundreds or even thousands of sub-agents. You can have even multiple subgraphs talking to each other, so you can have multiple supervisors talking to the mega boss supervisor, if you like. It depends on your architecture. So I want to leave you with some key takeaways. Treat your LLM like a CPU, not a hard drive. You can store your context by using those techniques in flat files, and you have the tools to retrieve them when needed. Do delegate work to sub-agents to do some more specific tasks, right? Imagine them as a junior business analysts or junior developers for your main agent. Context is finite. It's expensive resource. Don't forget that as your context window grows, your consumption grows as well. Some people think that, yes, the context window is great, it's big, I can dump in the files, and I will get charged only for the additional information I add. So basically appending your list. No, you're not charged for appending your list. You're charging for the entire list every time you click send. And that list proportionally gets bigger and bigger and bigger as you keep adding more and more and more. And when both you and your agent get frustrated and confused, you end up spending much more tokens because you keep going back and forth, saying, oh, this is not what I meant. You stupid machine. I want you to do that. And then you click send. And what happens? All of that goes back to the machine. And then it gets back and forth and back and forth. And everybody gets frustrated. Your clients get frustrated. And everybody hates AI and say that it hallucinates. I don't agree. Like, AI has not hallucinated for me for at least last 3 years, right? At the very, very beginning, when we didn't have thinking models, it was a different story. But with the latest models, greatest models, if you know how to use them correctly, it is an amazing tool. And today's talk was about talking about some of the context engineering context, trying to raise awareness. Do you think of context as one of the key enablers for a successful agentic journey or a successful agentic application? It's no longer just prompt engineering. Prompt engineering was a thing 3 years ago. Context is a much wider thing because now we have agents, we have sub agents, so we can take on much bigger tasks. And the challenges of how can we manage context at scale? How can we manage state? How can we orchestrate our entire workflow without confusing those machines and forcing them to hallucinate? And I do encourage everybody to go and have a look at DeepAgents library. It is an open source. For those who are active contributors, please have a look at the issues board. Maybe you can contribute to the open source as well. Great. I can take some questions now. QR code if you want to connect. As I said, my name is Ant. I'm based in London, but I do come to Lithuania quite often. So I would be more than happy to connect and chat about some of your challenges, especially around context at scale.